Good afternoon, sir.
Good afternoon, madam. We are very honored to have you here as a resource person, madam. In spite of your busy schedule, you spared us your valuable time to share your deep insights. Now, let me take a few minutes to introduce you, madam. Dr. Anupriya Jain is currently working as a professor in Manav Rachna International Institute of Research and Studies, Faridabad. Her research interests are computer architecture and data mining. She has published in various international and national journals. She has also filed 3 Indian patents and were all of these 3 Indian patents were published. And her patents include real-time railway coach management system using IoT and also multi-user traveler system using smart card and protecting soldiers. These are the 3 Indian patents which she has filed and they were patented and they were published. And she is also a member of professional bodies like IAENG and Turkish Online Journal of Educational Technology and also International Journal of Emerging Technologies. And she is also a reviewer of for various journals like IEEE Journal of Biomedical and Health Informatics, Open Computer Science, WS and Scopus Indexed, International Journal of Intelligent Networks, International Journal of Technology Intelligence and Planning, International Journal of Cloud Computing, International Journal of Emerging Technologies, and International Journal of Advanced Computer Science and Applications. Thank you so much, ma'am, for sparing your valuable time to share us your thoughts in this FDP. Over to you, madam. Madam, can you hear me?
Thank you, sir, for your kind words. Thank you, Shri Vishnu Engineering College for Women for giving me this opportunity, especially Dr. Siri, who invited me for this talk. And I'm sure I can do some justice in regarding this particular FDP. Maybe we can interact and we can give some insight to my topic, which is machine learning. So, sir, can I present now my slides?
Yes, yes. Please share your screen, please.
Sir, is it visible?
Not, yeah, it is visible now, ma'am.
Okay, thank you so much, sir. And my voice is audible. Am I
Yes, ma'am.
audible?
Yeah, you are
So
audible.
shall I start with the presentation?
Yes, ma'am.
So my topic today is an introduction to machine learning. Actually, this machine learning is a buzzword today. So I thought of discussing what is machine learning, what are the basic pitfalls in machine learning, and how can we implement this machine learning for our research. So this is my very basic topic. We will interact with the basics of machine learning. What is the basic types of machine learning? And then we can discuss how we can how can we can extend this particular machine learning to our research areas. So basically, we will go about like this. What are the fundamentals of machine learning and what are the common machine learning pitfalls? Now, to start with machine learning, we must understand some kind of terminology which we generally use for this machine learning. So first is instance. Instance is nothing but it is a row. In database, if we say like we are creating a database of a patient. So the patient, the complete record of a patient is nothing but it is an instance. Now, what is the feature? Feature is nothing but it is the attribute which describes the aspect of the instance. For example, if I want to describe a patient. So the attribute will be the height, weight, age, contact number, name. So these are the features of that particular instance. Now, what is basically the outcome? Outcome is what we are trying to predict with our data. Suppose if I want to use the machine learning for diagnosing a disease called diabetes. So the outcome might be, am I diabetic or not? So it can be a binary value 0 or 1, or we can say it is yes or no. So that is the outcome of that particular instance. Now, what is the model? Model is basically, it is a representation or simulation of reality. How do we incultivate this particular instance or this particular machine learning algorithm so that a machine can behave like a human being? So that is a model. Now, what typically is a definition of machine learning? Machine learning, where does this machine learning comes from? It comes from the word, it comes from the basic area of computer science, which is the artificial intelligence. So we can say machine learning, it is a subset of artificial intelligence in the field of computer science, indeed, that often use statistical techniques. Why we are using statistical techniques? So that we can analyze the data, we can train the data, and we finally, after training the data, we are expecting the machine to behave like a human being, so that that particular machine can take decision on its own. So ML is basically, it is a general term. It includes, it is a pool of many algorithms and many methods. So generally, basically what we are using machine learning for, we are using machine learning for the concept of generalization. Suppose if I want to train a machine to diagnose a patient for a particular disease called, let's take diabetes. So we are generalizing, we are training the data so that if new data set come to us, we can predict whether that particular patient is diabetic or not. Now, machine learning, how do we go about this machine learning? So we have data. As you can see from the figure, we have data. Now data is inputted to the algorithm. Finally, we are taking some model. Model can be a supervised learning model. It can be unsupervised learning model. It can be reinforcement learning model. And finally, we are predicting our result. So mostly not, it is not designed, it is designed to demonstrate causality. Causality means we are using the cause-effect relationship. It is not that. We are generalizing the data, we are training the data, we are validating the data so that we can predict. Finally, if we are getting a new data set, we can predict on the basis of training which we have given to our machine so that it can take decision on its own. Now, what are the basic some common examples where machine learning can be used? So first example is email spam detection. We all are bothered with the spams, right? Now, email spam detection, what we can say, we have an email. Now this email is fed to the machine learning model on the basis of certain algorithm, on the basis of certain training. That particular machine learning model can detect whether this particular mail is a spam or not a spam, right? Next example is community detection. Community detection, or we can say this is concept is a clustering concept. Now we are saying we have different types of followers. First, red indicates it follows only Trump. Blue indicates it follows only Clinton. Purple indicates it follows both. Gray indicates it follows neither. So if we can cultivate, if we can combine these particular opinions, we have that concept who are supporting Clinton, who are supporting Trump, who can support both, who are not following anyone. So these are the community detection. Next is association mining. It is a common example in data mining algorithms. So association mining means given a set of transactions, we are doing multiple transactions on a grocery shop. Like let us suppose first transaction which you have done is bread milk. Second is bread diapers eggs. Second milk diaper beer cola. Fourth is bread milk diaper and beer. Fifth is bread, milk, diaper, cola. So if we can identify what is the association between the objects, if we can see the records 2, 3, and 4, we can see the correlation, like if a person is buying diaper, that person is also buying the beer. So the association rule which we can derive from this is diapers beer. Suppose if a person will come to buy a diaper, he will buy a beer, right? Next, what are the other examples of applied machine learning? Next is image classification. What is image classification? On the basis of particular image, we can identify which category to it belongs. Next is face detection, which we have mostly seen in our any social media platforms like Facebook. Face detection, it will particularly identify the face, and it will see want to tag. Do you want to tag this particular person as this particular name? So this is the concept of face detection. Stock prediction, on the basis of certain algorithms, on the basis of certain trends, we can predict which stock will go high, which stock will go down. Next is fraud detection. We can identify on the basis of transactions which particular transaction is a fraud, which particular transaction is a legal transaction. Next is risk analysis. Risk analysis can be done in any area of business. So we can identify where the risk is high, where the risk is low. Next is navigation. Navigation is where we want to navigate to a particular location. So these are the applied areas where machine learning can be used. Now, what are the fields and terms related to machine learning? As we can see with this diagram, computer science is a superset. In that comes the artificial intelligence. Again, artificial intelligence contains machine learning. Machine learning is basically divided into 3 categories: supervised, unsupervised, and reinforcement. Now, which we can see it as a broader term, cognitive computing. Now, what do you understand by the term cognitive computing? We are feeding some data so that that particular machine behaves like a human being. So we are inducing certain human capabilities to the machine so that it behaves like a human. Now, how it is merged with its statistics, because statistics also contains data. Now we have data science, data mining, we have traditional research, we have domain knowledge, we have data. So these are the basically interrelated field and terms which are related to machine learning. Next. Now, a basic confusing term. Statics only also we are dealing with data, and machine learning we are also dealing with data. Now, what is the difference between the two terms? How statistics is different from machine learning? Basically, they are largely overlapping fields, both concerned with learning from data. We are in statistics also we are learning from data. Same is the concept with machine learning. So how they are different? The basic difference is on the focus and the approach. In statistics, we are applying the focus. We are applying on the existing data. We are not generalizing the result. We have given the data and we are applying certain hypotheses and we are giving the prediction, but it is not generalized. So what is statistics? It is founded in mathematics. It is a field of mathematics. It is drawing valid conclusion based on analyzing existing data, making inference about a population based on a sample. One population is given, we are extracting a sample and we are deriving that particular hypothesis on that particular population, but that result is not generalized. Second difference is we are focusing on very few variables at once. Now, what is machine learning? It is founded in computer science. Basically, the main motive of machine learning is we are training the data so that it is seeking patterns, it is making prediction, it is giving the decision. That means we are generalizing the result. Often considers a large number of variables at once. We have a large data sets, we have large number of attributes. So prediction accuracy is very important to measure the model goodness. If the result is accurate, if we are giving that particular Result is true. So if it is true, we can say the accuracy is 100%. Right? So for while designing the machine learning model, the main emphasis is on the prediction accuracy. Now, what are the basic types of machine learning? As we have already discussed, machine learning is typically divided into supervised learning, unsupervised learning, and reinforcement learning. First is, what is supervised learning? Supervised learning, as we all know, we have a supervisor who is going to guide us, and we are doing what our guide says. A simple example of supervised learning is a child, a newborn child, or a 6 months or 8 months, 9 months child, we are giving the training to walk. We are again and again giving the training to walk unless and until the child walks on its own, right? So some common example of supervised learning is regression. Regression is we are identifying the relationship between two variables. X tends to Y. When the relationship is accurate, we can say if X is given, we can predict the value of Y, then we can say our learning is complete. Next is classification. We have given certain kind of students. Now we want to classify that particular student as on the basis of their height. We can say they are a short height student, they are medium height student, and they are long heighted student. We have given certain criterias. We are given certain data sets. Now when we can say that particular machine is deciding on its own, we are giving the height, we are inputting the height of the student, and if that particular machine can classify whether this particular student is a short heighted student, medium heighted student, or a long heighted student, then we can say our learning is complete. Next is unsupervised learning. Unsupervised learning, like we are not giving any input. The machine is judging on the basis of its capabilities. So the best example is clustering. Clustering is we are giving certain kind of data. Now on the basis of certain kind of similarities, that machine is creating certain kind of clusters. Next is reinforcement learning. This particular learning is basically used in game playing activities. Like if we can see with this diagram, a learner, learner is taking some action, environment, and it is giving the sensory input. If learner is giving the right kind of direction or the right kind of input, it is rewarded. Otherwise, it is penalized. So this reinforcement learning, basically it is used in game playing activities where a machine is competing with the human being. For every move, the machine is doing its best. When the machine is winning, we are giving the reward to that particular machine. If a machine is playing an illegal move or a wrong move, we are penalizing that particular machine for that. So that is a reinforcement learning where a kind of feedback is given on a continuous basis, right? Is this clear? Next is we have certain kind of data types which can be used in machine learning, because machine learning, we can say we are predicting, yeah, we are actually simulating a human to behave like a machine. So it can have any kind of data. It can have a discrete data. It can have a random data. It can have an image. It can have a sound. It can have a video, because machine learning comprise of any kind of data. So first is we have a discrete data. In this, the data is represented as an array. Here it is a decision tree. There two images are formed to represent the data. Now this is a keyword based data where we are giving certain kind of keywords for a particular data. Now we'll discuss with a short example how this feature extraction or engineering is done. The example is, as we have discussed before, it is the email spam detection. For email spam detection, we have generated certain kind of keywords, and this is a continuous practice. So we have defined certain kind of keywords on the basis of frequency of keywords. Now we are making the table on the basis of this. For example, if we say the keywords are money, pills, Mr., bad spelling, known gender or spam. Spam is my particular classification label that we have discussed in the terminology. Now we will give the output whether it is a spam or not. So with this example, if money is yes, pills is no, Mr. is no, bad spelling is no, known sender is yes. Okay? So it is not a spam. Second example, if we can see is money is no, pills is yes, Mr. is no, bad spelling is no, known sender is no. So that is a spam. So on the basis of these keywords, we can identify whether this is a spam or not. Again, on the basis of generalization, we are taking this particular mail. So we have predicted the output on our training data sets. So if it is correct, we can generalize this particular model. If it is not correct, we will again train our machine. We will again train our data sets. We will again give the accuracy to our data so that the machine behaves as it is desired, right? Now next is a decision tree. Decision tree, we can say it is a supervised learning model. Now in a decision tree, it is nothing but it is a multiple if else statements. So we have a root node where our decision tree starts. Now on the basis of decision, the root node is split into multiple nodes. Last, the green is, we can say it is a leaf node where we can predict the output, right? So root, it represents entire population or sample. It will get divided into two or more homogeneous set on the basis of decision, yes, no. Decision, when a subnode splits into further subnodes, then it is called a decision node. So as we can say, this is a level 1 for root node. Level 2, we have a decision node. Again, if we want to further split into a decision node, we can do it depending on the condition in which we are designing a decision tree. And the last node or the terminal node is known as the leaf node. So leaf nodes don't split. It gives a class or average value, or we can say it is the outcome node where we are giving the outcome. What is the result of that particular decision tree? So parent node splits into offspring node. A root node is known as a parent, and we have a multiple child nodes. Splitting. What is the splitting? It is a process of dividing a node into two or more subnodes. Branch or subtree. A further decision tree can be divided into multiple decision tree. A subsection of entire tree is called a branch or subtree. As we can see in this particular diagram, the area pointed red can be a subtree, sub-branch tree. Levels or depth, we can say what is the level of our decision tree. In this particular case, the level is 4. Until all the nodes are converted to a leaf node. Is this clear? Next. Now, how we interpret as a tree, how we interpret for the result. Now, a very simple example, is it raining? Yes. No. So don't bring anything. If it is yes, so we have to check, is it windy? No. If it is not windy, we can use our umbrella. If it is windy, yes. So is it extremely windy? Is it a storm? Yes. So we have to stay at home. If it is no, so then we can use our raincoat and we can move out. So this is how a decision is taken. So decision tree is nothing but it is a combination of multiple if else statement. Next comes very important thing, which is a data mining pipeline. How the data is generalized to our knowledge. We are giving a raw data and how this raw data is converted to our knowledge. So we have 4 stages for that. Stage 1, stage 2, stage 3 and stage 4. Stage 1 is the pre-processing stage where we are getting the raw data. Now the main task of pre-processing stage is to clean the data, to transform the data on which we require, and to perform the cross validation. Cross validation means we have the data sets. Now we will decide on the basis of 70-30, 80-20, what will be our test cases, what will be our training data sets. So this is known as the cross validation partitioning. Now with stage 1, we are getting the training data for that. Now we have the collection of all the attributes. Now this particular stage we are checking for the feature processing. Like for a particular data sets, we have, let's say we have 50 attributes for a data. Now we have to identify which particular feature is relevant for this kind of decision. So we are prioritizing that particular feature weighting. Next, feature constructions. What are the kind of features which we are looking for? And we will select that particular feature. Suppose for out of 50 attributes, we find only 20 attributes are relevant for this particular kind of decision. So we will select only the 20 features. Next is data modeling. Now we will select the method like what can be the model. It can be a supervised, unsupervised, reinforcement. Then we will optimize the parameters on the basis of the data. What parameters we can use, which are the basic instances which we can use for our data prediction. Then we will evaluate the result and the model selection. Here comes the validation data. And last stage is post analysis. We will assess the generalizability, like our machine is complete. Now we will give new data set. We will feed the new data for that to check whether the machine is performing as per our expectations. So we are giving the generalizability concept for that. We will interpret the result and we will externally replicate. If the machine is performing as per our specification, we can give this machine is now generating the knowledge. Right? So for this stage 4, we have the testing data where we can check our machine is performing as per the expected outcomes. Now we'll discuss next what are the common machine learning pitfalls. Why the machine learning fails. So first is everything which we are analyzing is nothing but the data. If the data is not correct, if the data is bad, if the data is dirty, if the data is noisy, if the data is duplicate, if the data is biased, if the data is sparse, so we cannot predict anything. Or what we will predict, maybe it is not the accurate result. Maybe the precision is not true. So anything which we are doing relies on the data, so our data should be correct. If the data is not correct, our machine will not perform as per the expected outcomes. Second common pitfall is the data leakage. Now we are using the data and we are filtering the data on the basis of our result. For example, if I want to check the weather forecasting and we are using only the relevant attributes, we are using only the relevant instances. So there is a common kind of data leakage. Out of 500 instances, we are taking only the 100 instances. So the data which we are analyzing may give you a false positive result. So that is the kind of data leakage. So we are identifying which data is usable, which data is not usable. And we are predicting that particular data. If our prediction is as per the specification, we can say the machine learning is successful. But if it is not predicting, our data filtering is not correct, we have missed certain kind of data. So the machine will not predict as per the expected values. Next is not defining the target problem. We are not sure what we want to analyze, what we want to judge, what our machine should predict. So what is that? A problem well stated is a problem half solved. I'm not sure what I want to do with that particular machine. So are we expecting a machine to behave like us? No, because our objective, our notions are not clear. So how the machine learning will behave as per our specifications? So this is a very important, not defining the target problem. Next pitfall is ignoring the exploratory analysis. We have done all the kind of analysis for the data, but we are ignoring them for the result. We are not considering this particular values. We are not considering this kind of analysis. So our machine will not predict the accurate result. Next. Some data which we are dealing, handling missing data. Some data which we are dealing, the data is missed for any reason, for n reason. It can be a noise, it is a sparse data, it can be anything. So now to fill in that missingness, what we are doing, we are removing that particular data. We are inserting some kind of data on the basis of certain prediction. We are encoding the data as the features. So this can also give you incorrect results. Next is we are ignoring assumptions. We have to assume a machine is a machine. So we have to assume a machine follows the principle of garbage in and garbage out. So we have to check your assumptions. If we are ignoring assumptions, so definitely our machine will not behave properly. Next. Representable does not imply learnable. We are saying that this particular data is representable. We can see the results, we can have the data, but it does not imply that we can learn from that particular data. We have to categorize, we have to analyze that what we are doing, what we are seeing with this particular data, is it correct? Maybe that particular data which we are representing now can give you result for this kind of instance, for this particular moment of time. But since that was representable, we cannot generalize that particular data. Next is very important, our sampling bias. We have lakhs and lakhs of records. Now, the total analysis is depending on the sample which we are using. If the sample which we are targeting, if it is correct, your machine will behave like a as per the desired outcome. If the sample is not correct, if the sampling basis is not correct, we cannot have the desired values. Next is overfitting, over analyzing the data, over considering the data. So again, this will give you incorrect results. Next is simplicity does not imply better generalizability. Very true. We can say the data is very simple. Like here we can see the example 3, 4. So by the formula of hypotenuse, we can check this particular value of x. But because this problem is simple, we cannot say it can be a generalizable problem. Simple does not mean it can be generalized. We are misconceived with this concept. A simple problem is always a generalized problem. We have to analyze, we have to give training, we have to do certain kinds of methodology so that this particular problem is generalized. Next is using the default parameters. Always that is a problem. We are using only the default value 0, 0, 0, 9, 9, 9. So basically always using the default parameters will not suffice you the machine learning concept. Now failing to use an appropriate evaluation metrics. We know the concept of accuracy, we know the concept of recall, precision, area under curve. If we are mistaken with these formulas, if we are mistaken with the accuracy, if we are mistaken with the precision, we cannot expect that what particular machine can behave as per our expected outcomes. Next is data dredging. Data dredging, very important. Sometimes we are doing the data analysis, we are not getting the result. So we are inducing certain kind of data so that we can get some positive result. This is known as data dredging. So if you torture the data long enough, it will confess. So data fishing, data snooping, p hacking is a another term for using data dredging. So if we are using an exhaustive machine, and if that particular machine is not exhausted, but if we are exhausted with the data analysis part, and if we are introducing certain kind of data so that the machine is giving the positive result, so that is the concept of data dredging. Next is mistaking correlation for causation. Now we are discussing ice cream sales and shark attacks. They are two different, totally, entirely different events. So we cannot correlate with them. Shark attack is a different thing. Ice cream sales are a different thing. So we cannot correlate for causation. So causation is cause-effect relationship. So, sir, I am finished with this particular presentation. Thank you so much. If you have any doubt.
Participants, if you wish to interact with madam, you can please.
Good afternoon, ma'am. I'm Dr. Swati. And I have a doubt regarding the example what you quoted, ma'am, regarding the diapers, beer, and everything. Like you have given 5 different quotes.
Yeah. Shall
In,
I go to that particular slide?
Yeah, ma'am, please.
Yes.
That part was a bit confusing. I mean, I didn't get like how can you, make conclusions that the person would buy these.
Ma'am, this is an example. There are 5 kind of transactions, right? So
Yes,
first transaction, are you able to see this particular slide?
Yes, ma'am. Yeah.
So it is bread, milk, right? Second transaction is bread, diaper, beer, and eggs. Third transaction is milk, diaper, beer, and cola. So diaper and beer sound weird, but if we can see the transactions in 3 transactions, there is a correlation. Like when a person is buying a diaper, he is buying a beer. 2, 3, and 4. When you see the transaction IDs 2, 3, and 4, can we derive the correlation between the two?
Okay.
Other transactions, like you can see bread and milk. So in second transaction, bread, milk is absent. If we can see milk, bread is absent, right?
Okay,
bread
right.
and milk here.
My doubt was like, how can we correlate these two products? So that was the doubt. Right?
This example,
Okay, right,
we can use any kind of item like diapers and beer. We can see diaper and suppose, sorry, we can say infant food. So we can relate with that.
Okay,
We are only checking on the basis of transaction which particular item is coming together. So this is the kind of association which we are using.
Okay, right. Got it, ma'am. Thank you.
Ma'am, is it audible?
Yeah.
Okay, ma'am. When we are going for the evaluation of recommender system, what kind of metrics we need to use, ma'am?
Sir, can you repeat again?
I'm going to design a recommender system. So how can I evaluate the performance of a recommender system, ma'am?
Recommender system, basically what is that particular recommender system? We are taking on the basis of transactions. For example, a recommender system, we can check if we are designing a recommender system for buying a mobile phones, right? Can you quote an example which you are looking for? Which kind of recommender system which you are looking for?
Okay, ma'am. We can take a general recommendation.
General recommendation like buying a mobile phone? A brand of the mobile phone?
Journal recommendation. It's a journal.
Okay, general recommendation system. General.
No, ma'am. Journal. Springer. I want to find the Springer journal which is suitable for my paper, for my research work.
Okay, so then you have to search for the keywords. Then you first is the broad area which you are searching for. Then the keywords which you are looking for. In that particular keywords, you will check which kind of journal which will fit into your particular area of research. So that is the recommender system which you can use for the journals.
Okay, what kind of metrics for the evaluation?
Metrics is basically the metrics for general evaluation score, which we have the citation score, which we have the listing score, Scopus, Web of Science, SCI,
Ma'am,
SCIE.
ma'am, one second, ma'am. I'm not asking about in selecting a journal parameters. I am not asking in the kind of publication. I'm asking in the term of machine learning.
Can you reframe your question, sir? I'm not
Yeah,
getting
ma'am.
actually. Yeah, please.
Okay, ma'am. I'm going to suggest the recommended system. I'm going to suggest the journal to the user. Okay.
Okay.
So I want to do the information filtering, right? So
Yeah,
after
yeah,
that,
please.
how can I evaluate? So what are all the metrics? Okay.
Again, the metrics for
Okay.
the journal. Yeah. Evaluation criteria for the user for selecting a journal. You are asking this.
Yeah, ma'am.
So first is my broad area, my keywords, and the basis of accuracy will be the journal citation score,
Okay, ma'am.
your Scopus listing, your Web of Science index, and your
Okay, ma'am.
H index. H index, yeah.
Okay, ma'am. Thank you.
Dr. Santosh, I have shared some information in the WhatsApp group. Just go through it. That will be helpful for you for recommendation systems.
Thank you, sir. Thank you very much. Thanks for your time. Thank you, ma'am.
Participants, if you wish to interact with madam, you can please.
Sir, actually, I have to leave. Actually,
Yes, yes. You told
certain
me like you
engagement.
have you sent
So,
this.
if there are
We will conclude, madam, within 1 minute. Anuj Garu, please, sir.
Sir. Thank you very much, Madam, Dr. Anupriya Jain, for your valuable thoughts about introduction to machine learning. You have clearly explained about the applied areas where machine learning can be used, like spam mail detection, community detection, and so on and so forth. And you have also differentiated between statistics and machine learning. And you have also spoke about common machine learning pitfalls, like working with bad data, data leakage, not defining the target problem, and so on and so forth. Thank you so much, madam, for your wonderful contribution to this FDP. You have enlightened us with the deep thoughts about machine learning. Thank you very much, madam.
Thank you, sir. Thank you, Anuj, sir. Thank you, Dr. Siri. Thank you, Dr. Thank you, the entire fraternity, for a patient hearing to my talk. Thank you so much. And we'll be expecting more such sessions in future. Thank you so much.
Thank you. Definitely, madam. We'll collaborate in future in academic endeavors. We'll do that.
Thank you so much, sir. Thank you, Dr. Sri.
Okay. Have a nice day, madam. Thank you.